take two organic molecules and literally welds them together, holds them together so that they now form a single organic molecule. And we're going to look at three different ways it happens. And the first thing we want to learn about are called etherification reactions. So in biology, has anyone learned about ethers? Does that ring a bell? It's not as complicated as it sounds, I promise. It actually just works like this. Two alcohols join together an ether. And you are going to tell me chemically what an ether looks like just by predicting the outcome of this reaction. Because you guys are clever like that. I have faith in you. All right, so two alcohols. So let's keep it simple. What's a simple reaction between two different alcohols we could use here? It's got to be an organic alcohol, so it's got to have some carbon involved. A difficult one. What do you got? Give me one. I'm just going to be like, I'd like to do 3-methyl-2-butyl. Yeah. Come on. Give me a nice simple alcohol. Okay, I've been given methanol. That's a nice easy one. So let's do methanol. What's methanol look like, of course?
Carbon with an alcohol.
Very good. So carbon, it's got its usual complement of hydrogens, except that in place of one of them, we have an alcohol. Good. So we're going to take methanol and we are going to react it with what is another almost as simple alcohol. Ethanol. Good. So ethanol looks like this. And what do you suppose, just for the purpose of imagining that these are going to react, where am I going to draw that alcohol? Left side or right side? What do you think? If you had to predict. Yeah, I think you're right. I'm going to put it right here. So these two things are going to react. The reaction is going to occur between what, do you suppose? It's a distinct possibility. What are you talking about?
No, HO is the same thing. Oh, you didn't put OH.
No, of course, like, not only is it right, which it is, it has to be that way. Because what is not bound to the carbon? The hydrogen. Right? Has to be that way. Right? Like if I drew this like this, that's nonsensical. That says that we have a hydrogen bound to a carbon that's also bound to an oxygen, and the oxygen's only making one bond. That doesn't make any sense. So, fair enough. They probably do, but it's beyond my understanding of chemistry. So the reaction's going to happen between the alcohols. Now, I want you to predict the outcome. You tell me what's going to happen here. What do you think? What do you think? I'm going to tell you right now, there's two products. What do you think? Who wants to guess one of the products? If you go first, you probably get to guess the easy one. What do you got? Water. I think you're right. I think that this hydroxide is going to join with that hydrogen, and they're going to make water. All right. Now that was the easy one. Feeling brave, Zach Brown? Okay, what do you think the more complicated product is?
Propane? Is that it or no?
You're on the right track, but think, what did we use? We used the hydroxide on one side and the hydroxide on the other? No, what did we use from the ethanol in this case? Just the H. What's left? The O. So what do you think? Give me a shot. What do you think the product's going to be? You have to name it, but talk me through it. What's it going to look like? Okay. Let me ask you, have we broken this bond? So I'm going to start on the right side of this thing then. Have we touched these hydrogens, this hydrogen? So I should expect all that to just be the same, right? We haven't touched any of it. And you said I haven't broken this bond. So that oxygen is still there. What bond did we break? Yeah, so we broke this bond, and we broke the bond from this oxygen, right? So did we touch this carbon or these hydrogens? So the carbon's still there. The hydrogens are still there. What's it going to do? There we go. And now we've taken two organic molecules, methanol and ethanol, and we've welded them together to make this. And this is an ether. Now, an ether is always just a chain stuck to another chain with what in the middle? Yeah. So an ether is two chains with oxygen between them. There are two naming systems for this. I'm just going to teach you one of them. I'm going to write one of them down once, and we're never going to look at it again. You are welcome to use that if you like. It's not wrong. I will mark it right, but it's not what I'm going to teach because it's out of date. They used to do short chain, long chain, ether, and that's how they would name it. In which case, this one would be called what? So methyl, ethyl, ether. Okay, that is an old naming system. It's not what we're going to use. I mention it just because you might see it. The advantage is they have the word ether in the name. The disadvantage is it sucks. So here's how we think of it now. In the new version, we think of the short chain and the oxygen as a functional group. So we do short chain ending in oxy, and then just the name of the long chain, totally normal. And this is what we will use. So that would mean in this case, we would call this what? So, yeah, but not ill, just methoxy, ethane. Again, these are both accepted namings, but the new, more current version from IUPAC is down below. Yeah. That's a good question. Let me look that up. My understanding is that everything IUPAC now is one word. So it should be one word, but let me double check that. The top one definitely had spaces. My best understanding is that in the newest version of IUPAC, we don't put spaces anywhere. But let me get back to that tomorrow, just to make sure I'm right about that. Because to be honest with you, I think that I have been inconsistent, but when I actually wrote this down here, I wrote it without a space every time. But I just want to make sure, because then when I wrote it down here, I naturally put a space in. Perfect. All right, let's look at a second example. And I want you guys to do this one. Let's do methanol all by itself. In which case, what can it react with? Itself, that's right. So methanol alone. And I want to mention now that these are usually catalyzed also with heat. And you're going to see this coming up a lot, also with a strong acid. So strong acid present. A lot of these organic reactions require you to have a strong acid present. If you take university organic chemistry, you'll see why. In this case, methanol by itself only has methanol to react with. I want you to take a minute and draw it out. Yeah, you're going to have to draw two now. Yeah, you're going to have to draw two.
I get the magic pen.
Yeah, do you want to draw it on there for me?
Do we get to use the rainbow pen?
No.
Oh.
No, don't.
I don't get to use the rainbow pen. Oh, I don't like. Don't like using this thing. My writing on here is atrocious. Yes. What did I have? I had a
Is that how you keep that now?
No, I made a mistake.
Use the back of the pen.
Is that? Oh, it's an eraser. Oh, it's magical. See,
See?
I know.
In a formal sense.
Okay, it's
just
a
for your
tree
notes,
now.
don't worry about it.
Oh,
In a formal sense, you're always welcome just to write like CH3. You're welcome to use a stick diagram. Trying to see the sticks without anything on them is not one of the exceptions. Again, for your own notes, don't worry about it. Just be aware.
Doop, doop, doop.
The finicky folk. Chemists. All right, so I know I mention this every time, but it seriously freaks me out just watching the writing just appear on the board.
It's magic.
I find it.
It's very
I find
haunting.
it alarming. But yeah, as we see here, if methanol is all by itself, it has nothing to react with. But
How do I move
another methanol.
the screen?
By the way, this should automatically get you
Thank you.
thinking. Geez, if I was
It's very
reacting
magical.
methanol and ethanol, would some of the methanol react with itself and some of the ethanol react with itself? And guess what? Yeah, it would. Which is why organic chemistry gets tricky and confusing. But if methanol is by itself, the only thing it can react with is itself. What do we need to catalyze it to make that reaction happen? We need a strong acid and we need heat. Good. And when we do that, we get water because the two alcohol groups have between them 2 oxygens and 2 hydrogens. They will take most of that, 2 of the hydrogens, 1 of the oxygens, and they will make water. What remains? That oxygen, which is going to bridge those 2 organic molecules and stick them together. We call that an ether bond. Ether bond. And in this case, on one side of the chain, we have a methyl group. On the other side of the chain, we have a methyl group. Obviously, you just have to pick one as your shorter side, and we would name this what? Yes, that's correct. Yes,
I didn't know.
I enjoyed the up tilt at the end. Mathafi? That is correct.
There you go. Your magic pen is back.
Thank you. All right, very well done. So these are etherification reactions. By the way, these are types of what we call dehydration reactions. Now, I hate that name because dehydration reactions make water, which to me is just nonsensical. But it's talking about the molecules themselves. The molecules are giving up a water, I guess, but it's terrible naming. Like that's a stupid. I know when I think of dehydrating, I think of water just appearing out of nowhere. It's bad naming. And this is an example of scientists being like too clever by half for their own good, right? But there we have it.
I picture Gatorade. I don't know why. Maybe years back.
Yes. Have you had Gatorade recently? So it's not good. Like it doesn't taste good. My wife's been really sick, so she has to drink Gatorade. So the other day I went to the fridge and it was like the only thing in there, and I was too lazy to go down to get something out of the garage and bring it into the fridge. So I drank some Gatorade. It's like really salty and like it's not good.
Oh, yeah. Oh, yeah.
Is it? Is Powerade better? Oh, this is good to know. Are you saying I should splurge and buy my wife Powerade? I'm going to buy some on the way home. And won't I look like a good husband? So another type of dehydration reaction is what we call esterification reactions. And don't you worry, you already know how to do them. You already know how to do them. So an alcohol and a carboxylic acid less common spelling of acid with no C. Form an ester. And again, if you've taken the 12U bio, then you've had to do all this biochem to death, and this should haunt your nightmares. Have you taken the 12U bio? Yeah, haunt your nightmares.
It haunts my nightmares from the last time I took chem. I don't think Merck did this with us.
Did you not have to do all this crap?
I think she skipped it because we had grade 12 chem.
There you go.
Before.
Yeah, which is reasonable because yeah, there's in that 4U bio, there's a whole biochem unit that is like it's tricky. It's a tricky one. Okay, so an alcohol and a carboxylic acid. Let's pick a real simple alcohol. All right, methanol it is. So we will take methanol. And I don't want the solution to involve two methyls because that won't teach you the naming in the most efficient way. So let's pick a carboxylic acid that has two carbons. First of all, methanol, what do I need to stick on here, obviously? There we go. And we're going to react this with the second most simple carboxylic acid, which would be called what? What would it be called?
It's called what?
Cream. All right, so what's the second most simple carboxylic acid, team?
Ethanol.
Well, not ethanol, but ethanoic acid. Very good. All right, let's shake all those March break cobwebs off. What makes something a carboxylic acid? It has to have a... Very good. That's exactly right. So it's got a double bond to oxygen, and it's got an alcohol. And does this have any carbons or any hydrogens? Oh, it's got a second carbon, doesn't it?
Yeah, it's got a friend.
We did ethanoic. All right. So there is our pal ethanoic acid.
We use this on acid stuff.
Well, you tell me. What do you think?
Like, use it on acid.
Yeah, what do you think?
I don't think acid could help. Oh, it does.
I want you to predict the outcome of this reaction. And I think you already have all the tools you need to know exactly what the product of this is going to be. Products, two of them.
Yeah, that was me the other day. The other day, that was me. I feel like it has three products, but I know it doesn't. H2O, oxygen, and then. No, it's
But you're having a mistake on your page. Circle it and say this is a mistake. And then when you look at your note, you'll remember, oh yeah, that's not right.
Well, he did dress up as a red Crayola alcohol. This is every
I've marked many tests with red pencil crayons.
Really?
Yeah.
I'm just trying to try on.
Red pens are like, they're great. It's astonishing. You become a teacher and like your red pens are constantly disappearing.
because students need them.
It's so infuriating.
Follow my teacher.
If I wanted you to feel right, I'd have like put happy faces all over it instead of this is right.
Yes, they usually do. They put a smiley face right to that first mistake.
When I first started my career, I thought I marked all in green. And then as you move along into your career, you become more misanthropic. And you're like, yeah, you get the red pen.
So,
The red.
so how bad do you have to do to get the black pen?
And then like, I was bad in chemistry. I don't know if I've done you guys, where I would just like on labs, just like, no, and a few exclamation marks. Did I? Yeah, I'm sorry about that. I get
I would know.
Me neither. I got a lot of just straight up question marks. Like just like no explanation.
Please explain what that. You put that on the like. I got one of the answers wrong on the test, and you just put a question mark there.
I'm
pretty sure I did that right. I have no idea what you're talking.
You can show it to me. Honestly, as a general rule, if I put a question mark on your work, it means I don't know where this came from. Just simple as that. Like, just I don't mean it disrespectfully. It just means I don't know how this relates to the question, so I don't know how to tell you how to steer that to what, you know. If we were having a conversation, I'd ask a leading question like, "What were you thinking with that answer?" And then we could progress from there. But because we're not having a conversation, I'm going to start that conversation by putting a question mark next to your answer. That's what the question mark means. It means I don't know what. And usually I sit there for a minute and go, okay, all right. So you looked at this and you thought,
I got it.
Okay.
I don't know. and then I give up.
Some students that just wait for the
I got it.
like they never ask questions.
I got
That's true. And I try to be proactive, but I'm not always very proactive. That's not one of my strengths as a teacher. That's something I'm always feel like I'm working on.
question mark on time.
But yeah, same. I don't know what I did.
Yes.
See, I got it.
Fair enough. Would it help if I said like, because I always hated like when you get something back and it would be like, come see me about this. You'd be like, I don't wanna. Like, no, leave me alone. I don't. Obviously, you're more interested in this topic than I am. I'm happy to be done with it. So I don't like to be presumptuous like that you care enough to come seek out why you were wrong. I'm happy to tell you if you do. Just come ask me. But yeah. Yeah, talk to me. What do you got?
You said there's only two, so I'm assuming there's water.
I like it.
And it's methoxy.
Don't try to name it. Just tell me what it looks like.
It's methane
Mm-hmm.
attached to an oxygen that's attaching them to an ethane that has an oxygen on the carbon that's attached to the oxygen.
Good.
Did I do it?
You did great.
Yes.
So you have drawn this, yeah?
No, that's too many bonds. The hydrogen's not supposed to be there.
So you've drawn this. Cool. Yeah, good. So this is what we call an ester bond. It's just like an ether, but we can tell it's not an ether because an ether comes from two alcohols. This is a giveaway that it didn't come from an alcohol because, yes, it's got the oxygen joining the two chains, but one of the chains has, yeah, it has this double bond to oxygen. And that makes this an ester. And I think you're going to like how we name them. Okay, when we name an ester, the main unit or the main chain includes the double bond to oxygen. Does that make sense? So the main chain includes all this jazz, and this would be considered the side chain. And so if this is a side chain, you know how to name it. The first thing on this name is going to be, yeah, so it's going to be not methoxy. Nope. Nope. If it were methoxy, that would be an ether, but this isn't an ether, it's an ester. We've said that this is considered the side chain, just this. So this is just named what? If this was attached to like a regular old carbon chain, we'd call this a what group? Methyl. So it's methyl. And you ready for it? It's so good. One more ending. Is this the last ending you're going to have to know?
You added an.
Oh, it better be? Oh, well.
I don't have.
We're doing amides tomorrow then. I'm glad we discussed this.
You added
Ethane, but we drop that pesky E. And how do we signify that it's an ester? Oh, wait.
Oh, wait.
Stupid.
Oh, wait for it.
Rhymes with no, wait. Right?
No.
Oh, wait.
Oh, wait.
So methyl ethanoate. Isn't that lovely? Like, just seriously, that's lovely, right? Methyl ethanoate.
The old one for the-
Like just chain ether?
Yeah.
Yeah.
It actually, the way you wrote it out, it looked nice. It rolled off the tongue.
Yeah. They do not roll off the tongue. You're not wrong. All right. So when we put an alcohol together with a carboxylic acid, here's the deal. The basic naming goes like this. The alcohol will always be the ill at the beginning. Does that make sense? Because it doesn't have the double bond to oxygen. So whatever the alcohol was, that will become the beginning of the name. And then the carboxylic acid, I'm just going to shorten it to carboxyl here. Oh, wait. So because this was methanol and ethanoic acid, this is methyl ethanoate. If I did, I don't want to draw it, but just so we could predict it, if I did propanol, by the way, these have to be, for the purpose of this class, we are going to deal with these always being terminal carbons. They don't have to be, but for the purpose of what we do here, we're going to deal with terminal carbons. If I had propan-1-ol reacting with, oh, I don't know, butanoic acid. Again, I don't want you to draw it right now. Be a good little homework question to draw it. But what would the name of the product be? Yeah. Very good. Propyl. And see if you can pronounce that ending the way it's going to want to be pronounced. It's getting close. Propyl butanoate. It's got this kind of weird stress. Isn't that nice? It's much better though, right? So propyl butanoate. So they put a longer stress on the "an" for this to give it a nice rollicking propyl butanoate.
I thought you were about to say qualification.
There you go. It sounds very like, I wonder how the British say it. The British pronounce all chemistry stuff lovely. Oh, no doubt. Like aluminium. All right, now, really quickly, really quickly, obviously if these reactions can happen forward, they can happen backwards. And once you know the reactions forward, it's not rocket science to figure them out backwards. So, how did I number? I feel like my numbering got out of control here. I'm going to make this a new subheading. So we'll call it Part 2. And these are called hydrolysis reactions. And the nice thing is it's all in the name. Hydro, of course, comes from hydros, which is the Greek word for hydro. Hydro is water. Good. And anyone who's taken a lot of bio should know this. Lysis means, sorry? Yeah, specifically it means to break apart. So this is taking one molecule and using water to break it apart. Which makes sense because in the forward direction, all of these reactions produced water. How's it going over there? I couldn't find the rulers yesterday either. I had to steal Mr. Calford's. But he's got nice fancy new ones. They've got like a fake wood panel in the middle, like this one here. Right? So yeah, so go steal those. And if you want to just leave them in there and not give them back, I'm cool with that. So these are just dehydration reactions in reverse. And obviously, the dehydration reactions we learned, one made esters and one made ethers. So how many types of hydrolysis reaction do we have to think about? 2. One that breaks apart esters and one that breaks apart ethers. That's all. So let's look at our 4th example of the day. And what did I have in mind? Let's do propoxybutane and water. Propoxybutane and water. Propoxybutane, is that an ester or an ether? Ether. Ether is correct. Yeah. Right? It's got the oxygen in the middle, but it does not have the double bond to O. All right, so take a minute and draw that out. See what you get. Well, if you said right for the first one, you wouldn't be right. Now would you? No. You said it. Well, I prefer to say propoxy and butane. Well, yeah. It's wrong. I often reflect that, like, largely I think your generation is wonderful and lovely and that you're bright and probably, like, better educated and more socially engaged than my generation was. But you know it hasn't happened to you guys enough? People don't tell you you're wrong harshly often enough.
You kidding me?
That was a big part of my upbringing. Like, and like my generation's upbringing. We spent a lot of time being told that we were wrong and be quiet. And I'm not saying that's a good or a bad thing. It's just a difference. I don't mean in general. Like both. Are you? Yeah. I feel like at home is probably more frequent now. But education is a much more student-focused thing than it was when I was a kid.
Oh my God, it's such a bad idea. Focusing on the people you're teaching.
Again, I'm not. It's well. It can't. I think it's largely good. I think there's some drawbacks. I don't think anything else. Everything has positive consequences in it. Anything like the generation before that, my dad used to just get hit with like a cane and a strap. Yeah. Which I think probably did. I have no respect.
Yeah, I've never heard about the cane part. Who beats kids?
Yeah.
I think I got it.
I get it. My dad.
Are you having
Last night he showed up at 11 p.m. saying, "Joe, I'm back from ice fishing. I got these fish from my dad. I was asleep. 11 p.m. Oh my God. We got it fish together at midnight."
Real bonding.
This is not normal behavior. No, I don't think it's bonding. I'm not interested in bonding. Sleep. Is that a double bond?
No,
Okay.
that was just a.
Okay, then yeah, you're good. As long as that's not a double bond, you're good.
Oh, no, that was just like a.
Okay, propoxybutane. Talk to me. What's that going to look like? Do you want me to draw all the carbons and hydrogens, or are you happy if I draw a stick diagram? You're going to have to see a stick diagram of these eventually. Okay. So prop is 3, right? So 1, 2, 3. And then we are going to bond to oxygen, which I'm going to at least show in red. And then, so that's propoxy. And then what's coming off of that? Butane. So 1, 2, 3, 4. Let's double check this because I have a habit of counting these wrong. So 1, 2, 3 carbons on the left. 1, 2, 3, 4 carbons on the right. All right. This is reacting with dihydrogen monoxide is correct. Interestingly, its accepted IUPAC name is water. Yeah. Where is the attack going to happen? That's the language. All I remember from third-year organic chemistry was that Dr. Christina Pauls had backwards in her mind the words series and serious. So she would say, like, this is the result of a series of reactions. Joe, I'm worried you're not taking this course serious enough. She was right. And that every time she said the backside attack in class, I would laugh out loud and then be embarrassed. These are my two memories of third-year organic chemistry. So where does the attack happen? No, that's not true in this case. So where does the attack happen? On the oxygen, correct. So that is going to happen there. And what is the product, or what are the products, as the case may be, of this reaction? What happens? What was that? They separate because, of course, it's a hydrolysis reaction, hydrolysis. So we have that chain of 3 carbons and that chain of 4 carbons are now separate from one another. What is on this one? Alcohol, because it already had an oxygen and it's able to take one of the hydrogens from the water. There we go. And what about on this one? NOH, because there's the O and the H left.
Oh.
And this, of course, would be what? Is that specific enough? Propan-1-ol, very good. And this will be very good. Very good. Questions about that? It makes sense, right? If 2 alcohols come together to make an ether, then when you break an ether apart, you're going to get 2 alcohols, right? Cool.
Looks like a bat.
And our final example, what did I give you for this?
Do we need anything to do this reaction?
Ooh, my instinct is all you need is heat. Let me double check that for you. My vague memory is that these happen just in the presence of heat, like most decomposition reactions. But I will double check to make sure there's not anything else required. All right. And the other possibility, propyl ethanoate and water. Take a minute and work this one out. Again, if you need to go back and look right now, or if you need to ask the person next to you for help right now, do not worry. You're going to spend lots of time practicing this naming and these reactions and this drawing. There's really only 2 more lessons in this whole unit, but we're going to go at this for like 2 more weeks. Because we're really going to pound it into your skull until it's stuck there. Not physically, Schaefer. If you don't hit. Sure.
Technically, we do it.
You got a good point.
Rain it.
We did, I can't
We
do
just
that.
shouldn't. There's.
We are discouraged from hitting, Schaefer. Is that not accurate?
Yeah. Oh, I do.
Do you? Good. Well, that's better. Last semester, I felt like the 3 classes were pretty quick. This semester,
Wait, I sat here all semester long.
Last semester I had that. So it's moved. But now I think that's a better place.
That's pretty clever.
See?
I thought that they were there since like the first day of second semester. So I was just thinking like you could just left the box.
No, I constantly replenish them.
I did not realize.
Yes.
That's cool.
Yes.
I thought everybody's just stopping.
No, I usually have all this. Really well. Cereal is?
Cereal.
No, I didn't like cereal when I was younger. Now I like cereal. I like cereal with yogurt.
Do you mean actual cereal
or
the
yes.
Yeah, do you ever get like the Balkan yogurt that's like really, really sour, and then you can add your own honey, so you can get your own sweetness? Because I find regular just yogurt a bit too sweet for my taste.
I mean, I just eat like Lucky Charms. Like
Lucky Charms are delicious. Well, that's my point, is that like regular yogurt is great on its own, but when you add to sugar, it can be like, or to sugary cereal, it can be like sugar overload. But like a nice tart yogurt and then sweet sugar, it's a nice contrast. Is that weird?
I feel like you're that
Very
person that
specific.
goes to a restaurant and like orders a cereal, but then has them like.
No, but I used to. On the other hand, I used to, for many years of my life, be the guy who brought your food and said, "And here we have a charred steelhead trout fillet with a bechamel sauce." And blah, 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 blah. So it was kind of my job for a long time. Which explains why I like this job, right? Because you do that for long enough and you want to like just invite Schaefer to beat your head in, which of course she'd be only too happy to do because she's physically aggressive.
At least she's in the job market.
Touche. I can't argue with that. All right, talk to me. We got 5 minutes. What's propyl ethanoate? Yes, ma'am. Take your time. Well, propyl. How many carbons is propyl? Yeah, good. That's the one I always get confused on, but it's 3. And then ethanoate's going to be how many? 2. Okay, so that's easy. Now what's between them? Oxygen. And ethanoate means what's also coming off of it? Another oxygen with a single bond? Double bond. And we know that it's coming off the one with the O8 ending, right? So in this case, it's coming off the ethane. So there we go. What's it reacting with? Good old dihydrogen monoxide. Have you ever seen that like rather hilarious spoof about like, and did you know that 100% of your tap water contains dihydrogen monoxide? It's really funny. I normally don't go for things like that, but that one, I think that one's quite clever. Okay, so where is the attack going to happen? Did I make it a... I made it a butyl. Oh, for shame. 1, 2, 3. There we go. trust me. Who am I? I'm just a guy in an ill-fitting lavender shirt. You're just going to blindly write whatever I write? That's a terrible idea. Sorry? The sooner you learn that teachers have exactly like, especially where you are now, like, okay, I happen to have taken chemistry up to my 5th year in university, so I guess I have 5 years of this crap, but I could potentially be teaching this having taken chemistry in 1st year. So it is distinctly possible that your chemistry teacher could have 1 year's more, like if I taught you physics, I would have about 1.5 years more education in physics than you have. Why would you blindly trust that, right? Like, we're facilitators. We are not, we have a degree of expertise in what we do, but we are not, I'm not a chemist. I'm a chemistry educator, and it's different. And like, you can't blindly trust anybody. Good Lord, didn't anyone ever tell your generation, don't trust anyone over 30?
No.
Yes.
Well, don't trust anyone over 30. Also, especially don't trust anyone under 30. So where's the attack
I
happen?
think you can trust
When you're born.
Touche. I meant in the reaction. That's right. You can trust people on their 30th birthday. That's it. Yeah. Yeah, the attack's going to happen here, and we are going to get this propyl group with an alcohol, and we're going to get ethanoic acid. Very good. All right, so there we are. So we will carry on just practicing this tomorrow. You are not going to see new material tomorrow. We are just going to make sure we get this stuff worked on and figured out. But there is some homework up online. Be working on it. You're going to learn one more set of reactions after these, right? And it's a lot to keep track of. A lot to keep track of. So make sure you are, in fact, keeping track of it. Was there anyone who was not here yesterday who did not get yesterday's note? Like, you have to fill it in, but you have the physical paper? Cool. I will say by the end of the day, I am putting your progress reports in. There isn't even, frankly, a mark on your progress report. But if you have stuff that you owe me, please get to me. Otherwise, your progress report is going to say, I don't like you and you're missing assignments. You don't want to say that. That's 2 negative things in one comment. Yeah, no, it's true. I don't like any of you. Have a wonderful day, guys. Be kind to one